In this challenge, you'll be creating a game using the game console we set up in the previous video. This game will be a pirate game and should extend the game class we created previously. It should have a pirate class that implements the player interface. Your game will have different levels. Each level will have a list of towns, which can be strings for now. Use an enum for the weapon options. Weapon should have 2 fields, hit points that get deducted from a player hit by this weapon. Level, which is the minimum level needed to be able to use the weapon. Use an enum constructor to set this up. I also want you to think about how you could use instance or static initializers as you build these types. Okay, so let's have some fun with this one. This diagram shows a model of the main entities for my own implementation of the pirate game. I'm going to create weapon as an enum as suggested on the previous slide. The pirate class will implement the player interface from the last video. Finally, I'll create a pirate game class that extends game. I haven't included methods here, but this gives you a roadmap for what I'll be building. I'll be using the game console from the previous setup video. If you skipped that video, be sure to grab the source code from the resources section of this video. That code included a player interface and abstract generic game class that takes a type that implements player as a type argument. It also includes a game console that solicits input from the console to determine what actions to take. Any custom game actions should be set up on the new game class as methods that take an integer and return a boolean. This means I can store its method reference in the game actions field, which is set up as a predicate with an integer type. I'm going to put this new game and related types in the dev.lpa.pirate package. I'll start by creating the weapon enum. This will have 2 fields, a minimum level and a hit points value. The minimum level determines when a player can use a particular weapon. Hit points is the damage a weapon inflicts on an opponent's health. I'll set these up with these values already declared in parentheses next to each constant. I'll use a set of weapons, each with a unique first character, to make setup a little easier. I'm only going to set up data for 2 levels for this challenge. So I have knife, and that will be available at the first level, so 0, and it will inflict 10 points of damage if a player is injured by it. Next will be axe, again level 0, and this time 30 hit points. Machete won't be available until the second level, and that will hurt, so 40 points. Next is a pistol, that will also come into play at level 2 and deduct 50 health points. Next I need my 2 fields, both will be private and final since they won't change. The first is min level, an int, and the hit points, another int. I'll generate the constructor, followed by getters for both fields. I'll add some helper methods. The first method is going to get a weapon from the enum values, using a single character. It'll be public and static, returning a weapon. I'll call it getWeaponByChar, and it'll take a char I'll call that first initial. I'll loop through each enum constant through the values. I'll get the first character from the constant's name, and if it matches first initial, I'll return it from this method. If a match wasn't found, I'll return the first weapon in the enum. The next method will return a list of weapons available based on the level of play. This will be public and static, and I'll call it getWeaponsByLevel, and it'll take an integer level of play. I'll first set up a new array list of all weapons using enumSetsAllOf method to populate it. Next, I'll invoke removeIf method on that list and pass it a predicate lambda. I'll compare min level to the user's level of play. If the weapon's min level is greater than a player's level, it'll get removed from this list. I'll return the remaining weapons, meaning those that have a minimum level less than or equal to the player's current level. Getting back to the main class, I'll comment out the code from the previous video for the shooter game test. First, I want to test getting a weapon by character. I'll create a local variable weapon and assign that the result of calling my getWeaponByChar method with the letter P. I'll print the weapon out with its hit points and min level. Let's see what happens when I run this. You can see I get a pistol, its hit points are 50, and the minimum level equals 1. I'll test the next method, getWeaponsByLevel. I'll just use var here as the type, variable name is list, and that gets the result of passing 1 to that method. I'll print the weapons I get back. You can see I can use 4 weapons at level 2, the knife, axe, machete and pistol. Okay, so all good so far. I'll work on the pirate class next. I'll create that in my pirate package too. This will implement the player interface. This code doesn't compile until I implement the abstract method, which for player is just a method called name. I'll replace null with name, the field in that return statement. Right now I don't have a field for name. I'll add that now and a few other fields as well. Name will be private, final and a string. I want some game data such as the score, the health, the current level and the current town index. I could make all these integer fields, but instead I'll create a map with string as the key and integer as the value. If I find I want to add more pirate data later, then it's pretty simple to just add a new entry in the map. I'll keep a list of the towns visited while playing. This will include towns across all levels, and I'll make it a linked list so it'll be in insertion order, meaning the order the pirate visits the towns. I'll also add a field to keep track of the pirate's current weapon. I'll generate a constructor with just the name. I want to initialize my game data, and I could do that here in this constructor, but I think this is a good opportunity to use an instance initializer. At this point, the initialization process will be the same for every player. Maybe someday I want to save and restore a session, but that's for a later date. If I use an instance initializer, this code will get executed, regardless of what constructor is used. I'll put this block of code immediately after the constructor. First, I'll just add a comment so it's a bit easier to see this code is separate from the constructor. I'll assign game data to a new instance of a hash map since order doesn't matter for this information. We can create a map by specifying a series of key value pairs using the map.of method. That's what I'll do here. I'll start passing the list of key value pairs, so first health with 100, then score with an initial value 0, next the playing level, and that starts at 0. I'll use an index to keep track of what town the pirate's currently in. Next I'll generate a getter and setter for the current weapon. I'll remove the modifier on set current weapon so only classes in this package can invoke it. For the user data, I want to create some setter and getter methods of my own. First I'll create a value method. This should be package private so the pirate game can call it. It'll return an int and take a string, which will be the key to the pirate data element on game data. This can just return the map value based on the key passed. Next there'll be a set value method. This one will be private. Only the pirate class will be able to set this value. The return type is void, and it'll take a string for the key and an integer for the new value. This method will just place the new value in the map using the name passed. The next method will adjust a value in this data map. This will be private, again encapsulated, so that only this pirate class can adjust its own data. Its return type is void, and it should take a field name and an adjustment value, an integer. I'll use maps compute method here, using a lambda that simply adds the adjusted amount to the existing value. I'll add a special method for a player's health called adjust health. I'm doing this because health should never go below 0 or above 100. This method will be private and void, and take an adjustment argument, an integer. First I want to get the current value of health. The adjusted value can simply be added because the adjustment could be negative. Next I'll use a nested ternary operator. If the adjustment took health's value below 0, it will return 0, or above 100, it returns 100. I'll use setValue to save the new value. IntelliJ may give you a hint to change this code to a simpler form using math.min. You're welcome to take that suggestion, but since I haven't reviewed the math class, I'm going to ignore this for now. I'll be covering library classes like math in some detail in a later section, but that shouldn't stop you from exploring it on your own if you're curious. Next I want some game-related methods. These will be the methods use weapon and visit town. I'll make use weapon package private so my pirate game can call it, and it'll return a boolean. For now this will simply print the current weapon. It will return false to start with. The visit town method will be package private also and return a boolean. I'll set the town to a dummy variable right now. Later, I'll get the right town from data in the pirate game. If the town's not null, I'll add it to the town's visited field. I'll return false. So if this is used by the game, the play will continue. If a town couldn't be retrieved, the game needs to end, so I'll return true. I'm going to make a call to this method in my initializer code on line 29. Finally, I want to include a toString method, so I'll generate that with no data to start. I'll be replacing that return statement with code to print out my pirates information. First, I'll get the list of towns visited and cast that to a linked list, so I can take advantage of linked lists methods. Specifically, I want to use the getLast method to retrieve the current town. Next, I just want a list of simple town names without island names, so I'll set up a new string array. I'll use arrays.setAll to just get the simplified town names without the island included. I'll return the current town plus the pirate name and data. I'll include the towns visited for good measure. I can test this by creating a pirate in my main method. I'll create a new pirate named Tim, and I'll just print it out. Running that code. I get my pirates information. You can see it first prints the current town's data, in this case my town somewhere. Next I get the pirates game data, and a list of the towns the pirates visited, which of course is just my town. Okay, this feels like a good place to pause. In the next video, I'll be implementing the pirate game, so I'll see you in that next video.